Zalot studio channel. Zalot studio channel is focused on virtual physics lab. Virtual physics lab here. Okay. This is Zalot. That's the focusing area of physics. Okay. Now today's lesson is kinematics. Okay, rotational kinematics. That is velocity, angular velocity, tangential velocity. How to be getting of the angular velocity, and how to be get the tangential velocity of an object that revolving or rotating in circular. Okay, now this is the time to be discussing about the rotational kinematics, that is rotational motion. Rotational motion means whenever object travel in a curved path, their motion can be considered to be rotational. So angular velocity, the omega, is defined as the rate of change of angle subtended. Angle subtended means theta, that is angular displacement in last videos. So the faster an object rotates, the greater object that can be the angle covered per a given time. So the average angular velocity is equals angle covered by the moving object divided by time taken, theta over t. This is the average angular velocity. The average angular velocity means angle covered by time taken. Delta theta over t. Theta is measured in radian. The unit of angular velocity are therefore radian per second. When to be theta is measured in degrees, so the unit take the angular velocity is degree per second. In one complete revolution is equals to pi radian and time t. So the average angular velocity that equals theta over t. That means 2 pi over t. T means the period to complete one cycle. The period 2 pi over t. Okay, as the object follows a circular path, it also has a tangential velocity any given point. So this tangential velocity is a radius of path times angular velocity. Tangential velocity, tangential velocity, that is displacement over time, the rate of change of displacement, or rate of displacement, that displacement over t. So displacement, which means tangential displacement is equals r time angular displacement over t mean tangential velocity. Here r time angular displacement, radius times angular displacement, over t, theta over t mean omega, that is theta over t. Here theta over t, that is angular velocity, times r mean tangential velocity. So tangential velocity is equals to radius of the path or the circle times angular velocity. Here comes. So the two ladybug on a spin disk, the both ladybugs have the same angular velocity as they both cover the same angle in the same time. Okay, wherever the ladybug near the edge has the higher velocity, the higher speed. the higher speed. We'll come back to the simulation, into simulation here.
Oh, I'm gonna get a front.
Okay, the angular velocity can be taken, that is 57.3, that is 1 radian, that is equals 57.3 degrees. And is a ladybug, that move within the average velocities of 57.3 degree per second. 57.3 degree per second. This is the angular velocity. Here is the tangential velocity, you know, this one, tangential velocity, that is perpendicular with the radius. Okay, so the average angular velocity, or the angular velocity of at any point is equal. Okay, here the black one, it cover the angle suspended, equal time taken, and this is the blue one and the green one. Okay, it to be covering one revolution within equal time, so mean angular velocity is constant. Here the two ladybug have equal velocities, equal angular velocity, but not tangential velocity. You know, these velocities and these velocities are not equal, so have the greater radius have the greater tangential velocity. You know, tangential velocity is equals to r times omega. The omega is constant. Omega means theta over t. And tangential velocity, that r times omega. So r is what? Increasing or decreasing here. It is the radius over here. Okay, this tangential velocity and this tangential velocity is not equal. So again here taking angular velocity. Angular velocity is 57.3 degree per seconds, and the starting angle is 0, here 0 0, and the ladybug here 1 off, and the other here 57.3 degree per seconds. And now go. Okay, here the angle subtended is increasing within time t. Okay, so the angular displacement over time t that take or give have constant values, the inclined one, that is angular velocity. So the angular velocity is constant, which is what, 57.3 degree per second. Here 53 point here 57.3 degree per second. Here it is the angular displacement that is constant. Angular displacement, vertical one, and time. The angle, the graph of angular displacement, angular velocity over t, it is constant. That is horizontal line parallel to t-axis, that give the angular velocities. Here the graph, it gives what, acceleration. That means zero acceleration. It cannot be accelerated. And here the angular displacement over time t, that is the angular velocity. This is a graph can be taken about the angular velocity. Okay, thank you. This is a rotational motion. That the moving object is revolving the circle up to the circle or the curve path. So here the velocity direction, and here the indicating is the magnitude of velocities, the tangential velocities, and the direction. Okay, instantaneously the tangential velocity is perpendicular with the radius. This is the velocity direction. That's the tangential velocity direction. Okay, so the ladybug that revolve around the circle, this is the velocity. The dotted line is the angular velocity line. Angular velocity, that is the rate of angle subtended. The angle subtended here, the angle subtended divided by t, that is angular velocity. And tangential velocity, that is what, displacement over t. Displacement mean r theta over t, radius times theta, that the angle cover, angle subtended. So this is all about tangential velocity and angular velocity. That is the dotted one, and tangential velocity, here the vector of velocities. Thank you.
With